Hello, good morning everyone. Welcome to lecture number 17 of Basic Electrical System course. In the today's lecture, we will see certain complicated problems related to series parallel combination. So, as we all know that the series parallel circuits are the combination of series and parallel segments in one complex circuits. In the previous lecture, we have seen this theoretical part. So what happens in case of a complicated series parallel combinations? We have to thoughtfully solve this problem. We have to identify which are the individual resistances which are in the series combination with each other and in parallel combination with each other. According to it, a complex circuit is simplified and the equivalent resistance of the circuit is found out. Here we can see total 3 resistors in the circuit. 2 are in parallel combination with each other. For that, we can determine what is their equivalent resistance. And this equivalent resistance is in series with the one of the resistance. So this is a best method by which we can simplify a complex circuit and solve it step by step to determine the unknown quantities. Moving on, in the last lecture, we have seen a simple headlight circuit of an automobile. It is a combination of a series and parallel. Here, some of the components are connected in the series, whereas some of the components are connected in the parallel combination. Now, how to find out or how to diagnose the faults of a series and parallel combinations? This is also discussed in the previous lectures. So we will move on to the problems where there is a series and parallel combinations, and we have to find out the unknown parameters in the circuit. Here you can see there are 3 resistors in the circuit: R1, R2, and R3. But here this problem is simplified. Here we can see R1 and R2 are connected in series. So we can apply the series circuit law and determine the equivalent of these 2 resistances. For a series combination, the equivalent resistance is the sum of individual resistance. So here the equivalent resistance of R1 and R2 comes around 8 ohms. And this 8 ohms total resistance of these 2 of this first leg is in parallel with R3. So again, for this case, you have to apply the parallel circuit law and determine the equivalent resistance. So it comes around to be, how much it becomes? It is 8 multiplied by 8 divided by 16. Okay, so how it becomes? It comes around 8 8 is 64 divided by 16. 16 6 is 6, sorry, 16 4 is 64. So it becomes around 8, it becomes around 4 ohms. Now we know what is the equivalent resistance of the system's total supply voltage. If we divide the total supply voltage by this equivalent resistance of the systems, we get the current flow. So 12 divided by 4, it comes around 3 amperes. Now here, in case of this series parallel combination, similarly to the previous problems, we have to find out the total resistance of the systems, current flow to each branch as well as the total current flow, and the voltage drop across each resistance. Now looking on this problem, here the value of R1 is unknown. We have the value of R2 and R3, and this R2 and R3 are connected in parallel with each other. We have to find out what is the equivalent circuit, what is the value of R1. So here we can go step by step. We will first of all find out the equivalent resistance by using the Ohm's law. Here we know the value of voltage and current. So 12 volts and the current coming from the battery is 3 amperes. So it will use the value of 4 ohm as the total resistance of the system. Now here we have to find out the value of this equivalent resistance of R2 and R3. It comes around 2 ohms. This 2 ohms is in series with this. So here we know the total resistance 4 ohms. This 4 minus this equivalent resistance RT will give us the value of R1. That comes around 2 ohms. Now consider this example. I'll shift my focus over here. Now in this case, you can see we don't know the supply voltage, but we are having the value of this current coming from this battery, and we are having the value of the individual resistances. So let's find out. First, we have to find out the total resistance of the system. That is given by, here it is nothing but 4 and 4. This becomes around 8. And here also 4 plus 4 comes around 8. Now 8 multiplied by 8 divided by 8 plus 8 gives the value of 4 ohms. Now this 4 ohms is the total resistance multiplied by the current flowing through the battery, 3 amperes. It gives us the value of 12 volts, which is the supply voltage. Now coming on the next problem, here we have to identify what is the current flow in the circuit. Now here we are having the value of this. Okay. Now here this problem is typically complicated. First of all, you have to find out the equivalent resistance. And when you find out the equivalent resistance, you can get the value of current which is flowing through the battery. So here you can consider this R1, this R3 and R4 as a series combination with each other. Okay, and this R3 and R4 are in series. So the total resistance 4 plus 4, it becomes 8. Now this is in parallel with this R2. So this equivalent of this parallel combination comes out around 8 and this 8. It is given by 4 ohms. And this 4 ohms is in series with this R1. So 4 plus 2 gives around 6. So the 6 is the total resistance of the system. And if we divide it by the supply voltage, will give us the value of 2 amperes, which is moving through this battery. Okay, so this is our solution. Now this problem, this also looks complicated, but it is quite simple. If you break down the complex problem into a simple problem by identifying the series and parallel connections of the resistances, it can be simplified. So this is a homework for you. I will just explain this. So here you have to consider R2 and R5 as a series, found out their total resistance. Now this R3 and R4 are in parallel, find their equivalent resistance. This equivalent resistance will be equal to the equivalent resistance of this series parallel combination. And this will be parallel to each other. Again, find out their equivalent resistance of a parallel systems. Now this will be in series with this R1. So we will get the value of R1. We have to find out this 12 divided by 4 gives around 3 ohm, which is the equivalent resistance. And the method, as I explained now, by using this method, you can get the value of R1. I hope you have understood this concepts of series and parallel combinations. If any doubts, you can drop me the mail. Thank you for your attention and have a good day.